In this problem, we are given the following circuit diagram. We are told that in the difference amplifier shown, that VB is equal to 4.0 volts, and we are asked what range of values for VA will result in linear operation. Well, for linear operation, that means when we look at our op amp, we know that it goes from our lowest point, which is negative 10 volts, linearly up, and then to the highest point, which is the 10 volts for this example. We're getting the negative 10 volts from here and the 10 volts from here. Looking at this, we need a couple of things. First, we need to find our VA, so we know that this is going to be in our equation. We need to find our VB, so we know that this is going to be in our equation. We're actually given our VB to be 4.0 volts. And we need to find our V0, because when we're dealing with range, the output is the 10 volts of positive and the negative 10 volts here. So when I'm looking at this, I see node voltage method. When I'm about to do this, I'm going to have this as our first node, and the voltage for this is going to be our Vn for negative, and this is for inversion because we have a negative right here. And since we know our op amp is inverted, we know that we are going to have some negative feedback from our output that's going to go back actually inside of our op amp. We have to keep that in mind when we're doing the node voltage method. This is going to be our second node, and we will have a VP right here for V positive. We know that Vn is always equal to Vp. We're going to keep that in mind as well when we do our equation. So in writing this, first we're going to look at our Vn. We have Vn minus our VA is right here. So we'll have VA, and this is all happening over the 10 kilo ohm resistor. We can see this because our VA, if it goes up this way into the Vn, is going to be over here. So we're going to have 10 kilo ohms like this. Then we'll have a plus, and then if we look to the right, we will have our Vn minus our V0, and this is all happening over the 50 kilo ohm resistor, and this is because of the negative feedback. Then we're going to set this equal to 0. We want to simplify this, so we're going to multiply both sides by 50 kilo ohms. After we do this, we are going to get 5 Vn minus 5 Va plus Vn minus V0, which is equal to 0. If we add all of these together, we're going to get a 6 Vn minus 5 Va is equal to V0. This is our first equation. Looking at our second equation now for our V of P, we're going to get that we have a V of P, if we look to the very most left side with this part right here, Vp minus a Vb, and this is all happening over the 4 kilo ohm resistor. Next, we know that we have this 20 kilo ohms right here, so we'll have a plus Vp, and this is Vp minus 0 because of this ground, so we'll just have Vp over 20 kilo ohms of resistance is equal to 0 because we know all current going into a node is equal to 0. Now we are going to multiply this by 20 kilo ohms of resistance to get rid of the denominator. And if we do this, we are going to get a 5 Vp minus 5 Vb plus Vp is equal to 0. Combining like terms, we are going to get 6 Vp is equal to 5 Vb. And we know that our Vb, we're given this in our kind of explanation right here, is equal to 4.0 volts. So that means our 6 Vp is equal to 20 volts. Now we need to plug in for Vp. And we know that 6 Vn will be equal to 6 Vp because Vn is equal to Vp. So for this, we can plug in, and if we do this, we are going to get V0 plus 5 Va is equal to 20 volts. Now we can look at this part. What range of values for Va will result in linear operation? Well, for linear operation, we're going to need this part and this part. And since we're less than or equal to, we're going to actually include the upper and lower limits. We know our upper and lower limits to be this 10 volts and this negative 10 volts right here. So when we write this equation, it's going to be Va is equal to 20 volts minus V0, and this is in volts, over 5. So for our V0, we will be plugging in a positive 10 volts and also a minus 10 volts. And this will give us our two answers. In doing this, we are going to get the values 2 and 6. And that is how we would go about solving this problem. If you have any questions about the material we covered, you can leave them in the comments below, If you want more introduction to circuit analysis or notes for introduction to circuit analysis, they will be in the description as always.